Hello, everyone. Today, we shall be discussing on how to calculate the magnitude of an impulse. Magnitude of an impulse. Let's use our example question we have here for today. A football of mass 300 grams, travels horizontally at 12 meters per second towards a player. The player diverts its path so that the ball now travels horizontally at 45 degrees to its original direction at a new speed of 15 meters per second. What are the components of the impulse given to the ball in the original direction of travel and the perpendicular to this? What is the magnitude of the impulse? Now, we were given that a ball of mass 300 grams is traveling initially at 12 meters per second horizontally before it was diverted by a footballer to an angle of 45 degrees while it travels at 15 meters per second. Now, to resolve our angular input here, 15 meters per second, vertically and horizontally, we have impulse, which is equals force times time. Don't let us forget, impulse equals the product of force and the time applied. The product of the force and the time, which equals change in momentum, mv minus u. Now, to calculate our impulse, which equals ft, ix equals mvx minus ux, which is horizontal input. Our mass equals 0.3 into bracket 15 cos 45 minus 12, which equals minus 0.418 Newton seconds. When we input all these factors in the calculator. Now, our vertical, Iy equals m into bracket Vy minus Uy equals 0.3, which is equal to mass, minus our vertical reference, 15 sine 45 minus 0, which equals 3.18 Newton seconds. Now, we have our horizontal reference and our vertical reference being resolved. Now, to calculate the resultant actual impulse, then we have our impulse, the magnitude of impulse, which equals Rx raised to power 2 plus Iy raised to power 2, all in brackets square root. Now, we have our our horizontal 0.418 squared plus our vertical reference 3.18 squared. Then all in square root, which gives us 3.21 Newton seconds, which is our impulse, our outright impulse. So the magnitude, which is I magnitude, equals 3.21 Newton seconds, which equals our impulse. Thank you.